Okay, so we're going to go over some examples of graphing transformations and describing transformations. A nice sort of summary worksheet that we have so we can go over this stuff together to make sure you're on par and ready to go to describe transformations, to sketch transformations to a particular function, one of our parent functions, and last but not least, to even look at the function and see if we can figure out what the equation is by looking at the actual function itself. Okay, so there's quite a few things that we want to be able to get done when we're working on all this. Okay, so first things first, the top of the handle looks like this, section 1.8, transformations of functions. Okay, so stating the characteristics of a function. That is one of the expectations that we have to meet, overall expectations. So I want to say, how is A affecting it, how is K affecting it, how is C and D affecting it? So always off to the side, whenever you look at an equation, okay, and you have to sketch or have to understand how it's behaving or why it's behaving that way, you always want to try to, that can be too big, no, that's not bad. You always want to try to state all of your values. So my A value, remember, is multiplied by, but outside of the function. So there's the function, there's inside the function. This is outside and this is outside. Multiplied outside, so it's -2. Okay? My K value is multiplied, but it's multiplied inside the function. You're going to find it very close to x. In this case, the 3, which is the K value, has been factored out of the expression inside of the function. Okay? Excuse me. So as a result, my K value is just simply a 3. Now that doesn't mean that it's going to 3 times things. We've got to correct for that afterwards. And then we've got D and we've got C. Okay? D, okay, remember when we take D out, D is found inside the function, is a horizontal translation factor. And in this case, remember, we switch the sign when we take it from the equation to ascertaining what it's actually going to do. In this case, it's going to be 4 units to the right, a +4, once we take it out, okay? And then the C value, okay, always found on the outside of the function, okay, and that's going to be a 6 here. Remember, what's on the outside changes Y values, what's on the inside seems to change or changes X values, okay? So now from this, we have to write some descriptors. What are each of them going to do? Okay, so this function, okay, is a vertical reflection because it's negative, and stretch by a factor of 2. So stretch by a factor of 2, and a reflection of y is equal to f at x in the x-axis. Okay? In addition, we have the K value. The K value, and I'll have to sort of pull away and let the camera correct so you can see it. Okay, the K value is a 3. Now, a lot of people when they see the 3, they think, okay, it's going to be a stretch. Okay, so there's going to be, so this function is a horizontal. Now, is it a stretch or compression? Remember, for the K value, it's 1 over K. So we're multiplying our X values by 1/3. We're 1/3ing those functions. So it's a horizontal, and it's making it go closer to the X-axis, so it's compressing. So horizontal compression by a factor of 1/3. Okay, so horizontal compression by a factor of 1/3 of y is equal to f at x. Also, we have the 2 translation factors. Okay, all points of the function have been translated 4 units to the right and 6 units up. I I guess with proper language, we should say a vertical translation of 6 units upwards and a horizontal translation of 4 units to the right or in the positive direction. But that's still pretty darn good. Okay? So then when we look at this next example, we want to try and ascertain this next example, see if we can find out what's happening. Hopefully we're okay with that, guys. Okay? You do have to be able to do that and use the appropriate language in that situation. Again, here we've got an A value. We should be pretty good at finding it out there at 1/2. We've got a K value of -1/3. So no reflection vertically, but we have a reflection horizontally. We've got a compression vertically, but here we've got what looks like a compression, but no, flip it, or 1/1/3. That's actually going to be a stretch horizontally. And then we've got the D value and the C value. D would be a problem if this wasn't factored, but because it is factored, we're okay. So the D value is going to be a -2, and then -5 for the C value, okay? Again, vertical translation 5 units downwards, -5. Horizontal translation 2 units this way, so it's going to go this way and it's going to go down. This one is going to flip it, but it's not going to flip it up and down. This one's going to flip it from this way over to this way, or from this way over to this way. It's going to be a flip in the vertical y-axis, or a reflection. And of course, it's 1/1/3, or 3 times. It's going to be a stretch, pulling it outwards this way. Okay? It's also going to be a compression, so we're going to stretch it this way and compress it this way. Okay? So it's really going to get wide and sort of, I don't know, skinny. I don't know, whatever you want to call it. Okay? Or really, really fat, depending on your perspective. Okay? So what we're doing, okay? So this is a vertical compression by a factor of 1/2, and a horizontal stretch and reflection, and the stretch is by a factor of 3. Okay, I know it says 1/3, but remember, 1/1/3 becomes 3. Okay, it's the opposite of what you expect. You'd expect this to compress, flip it, it becomes 3. Okay, when compared to y equals x. When compared to y equals x squared, or y equals f of x, I should say. And every point is translated vertically. That's up and down. This is my up and down guy. Vertically, or I can't spell that. Mr. Henry. Vertically, 5 units down. And horizontally, 2 units to the left. When compared to y equals f of x, whatever the parent function may be. We don't even know what the parent function is, and it doesn't matter. It's the same thing for every one. Even some of the crazy ones we're going to learn about, not crazy, but more unusual ones, we're going to learn about later on as we work through the course. We learn about the exponential function. We learn about the sine function and the cosine function. So the next thing that we're going to do, so hopefully you're okay with that. Okay, have a look at that language. Okay, try your best to understand it. Hopefully you can read my writing okay. All right? When you magnify this much, the writing is still a little bit sort of chubbier than I would like, but it is what it is. Okay? Now what we're going to do is we're going to graph a transform function. And we're going to graph this transform function 2 ways. So one way, okay, we're going to use our mapping. And 2 ways, we're going to use our step-by-step method. Okay? So for the step-by-step, I'm going to do that one first. And the reason why I'm going to do that one first is because I can figure out my A, K, D, and C value here, and then use the same result over here. okay? Because I kind of need the letters here, okay? And I need to write out the mapping rule, and then I'm going to have to do a little table of values all the way throughout, okay? So, actually, maybe I'll, the step-by-step maybe I won't, the step-by-step maybe I'll just do right on the graph, right? So we'll go step-by-step. And I may want to have, extra room so I can do the mapping technique. So maybe I'll create my mapping rule over here, and then I'll go ahead and I'll do my table of values over here. So what is my A value? It's 3, which is going to be a vertical stretch by a factor of 3. Who am I stretching? There it is, the root function. The root function is the base or parent function that we have, okay? There's a 2 there, so that's my K value. It is factored out already, so my D value would be correct, which is 4. Again, don't forget to switch the sign. And then my C value, which is a positive 1. So it's going to translate 4 units to the right, 1 unit up. The 2 for the K value is actually going to compress it horizontally, okay? So you have a look at those, you get used to those. I'm going to do the step-by-step first so we can get a visual, and then I'll do the mapping part second. Okay, so remember these if you can, because I need the whole graph. So A is 3, K is 2, D is 4, and C is 1. And I'll scroll back and forth. You know what, maybe I'll just go out that far. Yeah, maybe that's a little bit better. And there we go, we got them all in there. Well, A is 3, so just do your best with that. Okay, so I'm going to draw the basic function, okay? And the basic function, oh, the aim is good for the smart board here, that's good. Okay, so here's my basic function, okay, and that's going to be y is equal to the root of x, okay? The next thing that I'm going to do is I'm going to take care of my A value. So I'm going to take care of the A value that's 3. That's a vertical stretch by a factor of 3. That means I take the y coordinates and I'm only affecting the vertical stuff. A is a vertical transformation factor. I'm only affecting the vertical stuff. So 0 is going to get multiplied by 3. 0 times 3 is 0. So that's going to be an invariant point. It's going to stay in the same spot. Okay? See this 1 here, this y value of 1? Maybe I should make that a little bigger so we can see it a little bit better. Then we can go back and forth. That's fine. That's what we'll do. Okay? So we can see that a little bit bigger. So see this y value of 1? I'm going to times that 1 by 3. So it's going to stretch the y, keep the x value the same, but take this 1 and multiply it to 3. 3 times this tall. Okay? In addition, we've got this one that's too high. We're going to multiply that by 3, and it's going to become 6 high. So there is my A value taken care of. So I got 2 times the root of x there. Okay? Then what I want to do is I want to take care of my, I want to take care of my K value of 2. Now remember what a K value of 2 does. A K value of 2 takes the x values, it's a horizontal, so it's going to modify x values, it's going to make it fatter or skinnier this way, and it's 1 over K, so it's 1 over 2. So I'm going to half my x values. So that's what I want to do. I want to half my x values. So I'm going to go back to the super de-duper big one so we can graph this accurately. And I'll use a different color, okay? And I'm going to half my x values. Well, half of 0 is still 0. That's an invariant point there, guys. That doesn't change. Half of this x value here is a half. Maybe a little awkward to do it there, but take your time, you'll be okay. I made that point huge, but it's just so we can see it. You guys can see it effectively. Okay? And then what I'm going to do is I'm going to take this x value of 4 and I'm going to half that to 2. And I'm going to create this function, okay, that looks like that. And that's going to be y is equal to, it's still got the 2, because I branched from the green to the blue, step by step by step, but it's got the root of 2x in there too. So we've got, oh, sorry, I forgot my, I'm going to move here. This should be a 3, and so this should be a 3, I may erase that and maybe make it look a little prettier a little bit later on. But once I've done it in the video, it is there. Okay, so we've taken care of our A value, which is 3, tripled the height, tripled the vertical, and then we've actually halved the horizontal. So it actually looks like I've even made it even more vertically stretched, because a horizontal compression is or looks similar to a vertical stretch. It's not the same amount, it's not the same thing, but it does look similar. Okay? I'll actually talk to people about that if they want individually and tell you really what's going on there. Okay, and finally what we want to do is we want to take care of a D value of 4 and a C value of 1. So what that means is, maybe looking at the big picture here, what that means is that I'm going to take this blue function and I'm going to take that point and that point and that point and I'm going to shift it 4 to the right and I'm going to shift it 1 up. 4 to the right and then 1 up. And now that I'm actually realizing, I'm kind of scrunching it in a corner there. So what I may do is I may just reposition some of these labels just so that it doesn't look too busy. Okay? So I'm going to redo these labels. There we go. Redo these labels a little differently. I'm going to call the blue one, I'm going to put the blue one over here, and that's y equals 3 times the root of 2x. The green one I'm just going to put over here. Hopefully we can get the color associated with the actual function. That's 3 root x. I guess underneath here I can put y is equal to root of x. Okay? Now, what are we doing here? Again, we're going to a D, I need a different color. We're going to a D value of 4 and a C value of 1. I'm going to do both at the same time because I only have 4 markers and 4 colors. Okay? But you can go ahead and do D, move every point to the right 4. Okay? And then from that drawing, move every point boop, up 1. But most people, when they do their translations, are like, geez, I'm getting tired. Okay, I know what I'm supposed to do. Why do I break it into 2 pieces? And so that's what I do. I take this point, and that point, and that point, and I move it 1, 2, 3, 4 units over, and up 1. See? I knew that was going to be in the way. Anyway, okay. So, I take this 1, 2, 3, 4, and then up 1. And that's where this point is going to. This point, I go, and remember it's halfway in there. 1, 2, 3, 4, and then up 1. So it's going to be halfway in here. Okay? And then this point, 1, 2, 3, 4, and then up 1, and it's going to be right here. Okay? And then you connect the dots. Okay, and there you have it. And that's the final function. Okay, it's a little bit, I don't think I can magnify any more than that, but maybe I can move this over a little bit, give myself some room. Okay, this final function is already as small as I can. Y is equal to 3 times the square root of 2x minus 4 plus 1. Okay, that's the final function. Okay, and so I guess, I don't know if you want to sort of color that. That'll be what it looks like on my graph. Okay? What we can do now that hopefully we have that graph as effectively as we can, is we can use this graph here to verify my mapping question. But we'll see. All right? Now, the other technique that we're going to use is mapping. I'll go there. The other technique we're going to use is mapping. Okay? Now, the nice thing about this one, doing this one with mapping, is that there's only 3 points. So you only have to transform 3 points. So at least the math that you're doing is not too crazy. Okay? But you're going to do a wide table of values. And you can do these calculations off to the left or the right if you want to. Okay? Try to remember the key points for my parent function are 0, 1, and 4. Or 4, 1, 0 if you want to. You don't have to do it in any particular order. Okay? And then the y values are 0, and then 1, and then 2. Okay? So those are the values that we're going to transform. And we're going to do it sort of piecewise. So the first thing that we're going to do, if we have to use some decimals, we'll use some decimals. The first thing that we're going to do is, well, we'll take care of the y values. So the y values are multiplied by 3. Okay, that's what an a value does. So I'm going to go, and I'm going to go 3 times the root of x, right? So that's going to be the a value of 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. And then what I'm going to do is I'm going to take this value now that I've modified, and I'm going to take it one step further, okay? I multiply by 2, and then I add the 1. So I go 3 root x plus 1, okay? And then I add the 1, and so what do I do? 0 becomes 1, 3 becomes 4, and 6 becomes 7. Nothing crazy. And we can maybe go over and check to see if we're right yet. That's a y value of 1, a y value of 1, 2, 3, 4, y value of 4, y value of 1, 2, 3, 4, 5, 6, 7. Yes, nice. Okay, so that's working for us already. Then we modify the x values. And remember, k and d modify the x values. K is 1/2ing values. Remember, it's a 2. We flip it. It 1/2s things. Okay, so this is going to be the root of 2x. Okay, and so what I do is I half the 0, which is 0, and I half the 1, which is 0.5, and then I half the 4, which is 2. And then I add on the d value, which is 4. So 0 plus 4, so this is going to be root 2 bracket x minus 4. Kind of ugly there, but you know the marker is as fat as it is. So I take this and I add 4 to it, and I add 4 to it, and I add 4 to it, and I get these results. Okay, and those should be basically the table of values. Now, as ugly as it may seem, my table of values is actually, you know, hide all this stuff because this is my x and this is my y. Okay? This is my x and this is my y. Okay? Another way to look at it is to actually write down the mapping rule. Maybe I should do that also in black. So the mapping rule is, oops. I take each individual point and I take each x value and I multiply it by 1 over k times x plus 4. And I have a comma there that separates the x coordinate from the y coordinate. And then for the y, what I do is I multiply it by 3, so I go 3y, and then I add 1. And that's in essence what I did by doing these 2 different steps. Okay, doing these 2 different steps. In a lot of cases, what most people do, what they do is that when they do these top parts here, okay, when they do sort of the, 0, 0. When they do the top part here, this is x, this is y. This is going to be 1/2 x, okay? And then this is going to be 1/2 x plus 4. And this is going to be 3y, and then this is going to be 3y plus 1. And then that way it's more in tune with the formula. And so the 3y plus 1 is the y part of the coordinate, and then the x part of the coordinate is right here. So if I rewrite my table, or if I plot this table of values, I'll have to probably make it smaller now. If I plot this table of values on here, each box or each square is 1 unit. Okay, I put a line. I put a value at 4, 0. So I go 1, 2, 3, 4. Oh, sorry, at 4, 1. So I go 1, 2, 3, 4, and then up 1, and that's where 1 point is. Okay, and then I go 4.54. This is x. This is y. So I go 4.5, which is like 4 and halfway between 4 and 5, and then I go up to 4. And I go up to 1, 2, 3, 4. So you take your time with it. I can't do it very accurately here because the grid's a little bit small. And then finally, I want to go to 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And then I connect the dots from left to right. Or you can go right to left, or whatever you want to do. But in this case, left to right. And so as a result, what do I get? I get the function that looks like this. And this point, and this point, and this point should be exactly the same as if I did it step by step. 4, 1, 4, 1. Yes. 4.5, 4. That's going to be a little tougher to see. 4.5, 4. Oh, it's right there. Okay. And then we've got 6. 1, 2, 3, 4, 5, 6. And then up 1, 2, 3, 4, 5, 6, 7, 6, 7. Okay, and then that's going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay? And so as a result, these points and these points are identical to each other. Okay, and if you stated the domain and the range, which we're going to do now, then you'll have a really good idea of the fact that it's pretty much the same thing. Maybe I'll make it a little bit smaller. Yeah, I'll make it smaller. We'll do the domain and the range down here. Okay, so they're the same function, but I'm going to state the domain and the range. So the domain and the range. Now, the root function is a really good one because remember how I told you that the domain is always restricted by the d value in some way, shape, or form. In other words, the d value should appear in the domain somewhere. Sometimes it doesn't because if the function's symmetrical, it's just where the vertex is or the axis of symmetry is. But if it doesn't, then here we are right here, and that's the whole idea. So my x values go on in this direction, no problem, but they don't go back past this particular value. So we know that x and 4 have a relationship, that x has got to be greater than or equal to 4. And as long as it's greater than or equal to 4, as long as we connect the dots, or any value of x above that is no problem. And you can see that when you look at the root, right? Because if you look in the square root, if you give a number like 3, 3 minus 4 is -1. -1 times 2 is -2. We can't do the square root of -2. We can't have this bracket be negative. So that's where we get this restriction from. But also we can just see it on the graph. The other thing is my y value. My y value goes up, right, from here. So any y value up to positive infinity, no problem, but stops right here at a barrier right here. And the barrier that exists for y is at 1. And in this case, it's also greater than or equal to 1. And then as long as it is greater than or equal to 1, it can be any possible y value that exists. So there's our two techniques about how to graph. Okay, and you decide which one it is that you like more. Okay, you should really be able to understand and have to explain both. Okay, and it depends what your go-to is going to be, but you are responsible for understanding and being able to explain both of those. Okay, but you'll probably have a favorite when you have a choice. So let's move on to the next page. A couple more examples. One is a reciprocal function, one is an absolute value function. We got a little bit more going on with this one than we do have going on with this one, but people find these ones really difficult to do. So we'll do, for this one, I don't know if we want to do a step-by-step or if we want to do a mapping rule. It doesn't make a difference, okay? If you do the mapping rule for a reciprocal function, you almost have to basically make another point the asymptotes, okay? Because the asymptotes are really key for this. In fact, the asymptotes set it all up, okay? Now, the asymptotes always are at a particular location. Okay, so my asymptotes for any, they define where my function is, but my asymptotes are at basically x is equal to d and y is equal to c, always. As long as it's a single fraction, that's the way that it works. Well, plus the 2, the constant. Okay, so whatever the d value is one asymptote, whatever the c value is another asymptote. Okay, so the d value is like the vertical asymptote, and the c value is the horizontal asymptote. So we can look at it, and as soon as we see the d and the c value, we can draw our asymptotes right away. Okay? And that's going to help you do transformations and things like that. Now, some people are like, well, if I'm going to do this step by step, I have to start with the parent function. And absolutely you do, and then you do all the transformations, but in the end, you're going to be moving the asymptotes anyway. Okay? So, that's sort of an idea about how you want to do it. Okay, so if we're going to use the mapping rule, we have to realize that our asymptotes exist here. And I'm going to use the mapping rule here. The only reason why I'm going to use the mapping rule is if I sketch the base function, it really only has 4 points. I'm going to make it a little bigger here. And then we'll go back to figuring out what all of our values are. But when I do the mapping rule, okay, for the base function, there's the point 1, 1, and the point -1, -1. And that's for the equation y is equal to 1 over x, our reciprocal function. All right, where the x is in the denominator. Okay? So those are 2 key points. Another key point is going to be 2.5, so that's right here. Okay? And the other key point is going to be -2.5 right here. Now some would say there's another key point right here and another key point right here. It's sort of up to you how many points you want to transform. But if you know what your asymptotes are, you can do things a little bit more accurately. But we're only going to include these 4 points. Okay, so we're going to include the point 2 and 1/2, and we're going to include the point -2 and -1/2. Okay, so when we do the map, I'm going to erase those eventually, but when we do the mapping rule, okay, not only do we have to appreciate the asymptotes, but we also do have to include those points. So I'm going to go x and y. It's going to be a little scrunched, but that's okay. I'm going to go 2, 1. We can have a point at 0, and then go -1, -2, because remember 0 is when you sub it into y equals 1 over x, it's not allowed. For here, it's okay. Okay, and the resulting values are going to be 1/2, and then that's going to be 1, and that's going to be -1. These 2 points in the middle here are very convenient. These ones we do have some fractions with, so they're a little bit more challenging arithmetically to deal with. So you may want to put 0.5 and -0.5. Okay, if you're going to do the mapping rule, it's sort of up to you and how you roll. Okay. So let's go back up and we'll figure out I'll write the mapping rule up here, and I'll write the A and the K and the H, and the D and the C here. So first of all, for the A value, that's actually the toughest to see here, so let's leave that to the end. The K value is always right beside the X. There's no one right beside the X, is there? So my K value is, well, there's a 1. And you could, I suppose, factor out the 1, and that is what you should do. But if the K value is 1, that just means it's not going to do anything horizontally. Okay? And then we have this -3, not quite sure what that, I know what that one is. That's going to be C, because that's all the way out. So it's like completely on the outside of the fraction, which is the outside of the function. And the outside of the function is always where we find C and where we find A. But you say to yourself, well, where is A? What is A? Well, D I can see. D's not too bad. Right? It's an x minus 3 in there. So I just say change the sign and I get a positive 3. Okay? And then I make decisions. And the decisions that I make from here on in are more about, well, where is A? If you're to look at this more carefully, this -3 over x minus 3, in reality what that really is -3 over 1 over x minus 3. And if you can see it a little bit more clearly like that, then you can see that the A value is -3. But if you ever really want to find the A value for a reciprocal function and you want to sort of memorize it as a general rule, it's in the numerator of the fraction. The numerator of the fraction is the A value. Okay? So there you go. Sometimes the numerator and the denominator can cancel out, and so you have to be a little bit careful with it. Okay, but they're not variables that are going to cancel. They'll just be numbers that cancel out. So if I had an A value of 2 and a K value of 2, the 2 and the 2 would actually cancel out. Okay? And so now I'm going to see what I'm going to be doing here. All right? Now my mapping rule with all of these in mind, okay, is going to be x comma y. And it's going to turn into, now for the x part, remember it's going to be 1 over k, so 1 over 1 times x, which is just 1. Just x. Okay, and then I'm going to add my d value, plus 3. For my y value, it's going to be whatever a is times y, so -3 times y. And then it's going to be plus 2. So there's my mapping rule. Here's my mapping rule. Okay? So the first thing I'm going to do here is I'm going to multiply by 1. Well, if you're just going to make it x, it's going to be the same thing, right? It's going to be the same result. So when I make this bigger so I can actually write this size, okay, I'm just going to multiply by 1, which means it's going to be 2, 1, negative 2. Nothing crazy. And then all I'm going to do is go x plus, what was it again? My d value is 3, so it's x plus 3. So that becomes 5, that becomes 4, that becomes plus 3, 2, that becomes 1. 5, 4, 2, 1. Okay? And so those are my final x values. Now I have to do my final y values. There's a little bit more going on here. Okay? A is a negative 3, so I have to multiply by negative 3. So this is going to be negative 3y. And then finally it's going to be negative 3y plus or minus? Plus 2. Okay, so first I multiply my 1/2 by negative 3. That's a little awkward. That's going to be negative, and I'm going to make it 1.5, or negative 3 over 2. Just because it's easier for you to sketch it. This is going to be negative 3. This is going to be negative 3. Oops, sorry, positive 3. Positive 3. And then this is going to be negative 1/2 times negative 3, which is a positive 1.5. Okay? Then I'm going to add 2. So if you add 2 to this, this becomes 0.5. You add 2 to this, it becomes negative 1. You add 2 to this, it becomes 5. And you add 2... And you add 2 to this, and it becomes 3.5. Okay, so there are my final results. Okay, there are my final results. Okay? So 1, 3.5, 2, 5, 4, negative 1, 5, 0.5. But you also have to draw those asymptotes for you to see it effectively and draw it effectively. So my asymptote is actually x is equal to d, which is 3. And my other asymptote is y is equal to 2, which is c. Okay? And so I'm going to draw those asymptotes. One at y is equal to 2 and one at x is equal to 3. I should be able to do this from a smaller version. I'm going to clean this up a little bit. Okay, so from a smaller version at x is equal to 3, 1, 2, 3, I should be able to draw an asymptote that goes like that. Excuse the fact that I don't have a ruler. Okay? And then draw another asymptote at y is equal to 2. So you go y is 2, and then you go boop, 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 boop. Okay? And then, of course, you sketch the function. Okay? You take 5 and 0.5. So you go 1, 2, 3, 4, 5, and 0.5, which is like right there. Nothing too crazy there. And we'll talk about why it looks the way that it looks afterwards. And then we'll take 4 and negative 1. So we'll go to 4 and then negative 1, which is right here. Okay? And then we'll take 2 and 5. So 2 and 5. 1, 2, 3, 4, 5 is right here. And then we go 1 and 3.5. So 1, which is right here, and 1, 2, 3 and a half, 3.5 is right here. Okay? Now, as far as connecting them, remember the way that it works. These points are going to have sort of a curvy part on this side of the asymptote. Okay? So if I draw the curve, it's going to kind of look like that. Whatever corner set up by the asymptotes that the points are in, that's where we're going to find this curvy line. And the same thing for this curvy line here. It's in this corner, so we put this piece of the function. Now you may say to yourself, wow, that looks different, right? Because usually it's in the top right and the bottom left. But remember, we have a vertical reflection. So that's what's going to flip it. This is going to go down here, and this, what's down here is going to go up here. There's no horizontal reflection. Okay, there's no horizontal reflection, but there's a vertical reflection. And then it's certainly been shifted 3 this way and 2 this way, because my asymptotes are usually at 0, 0, so you can see 3 and 2. It actually sets up kind of like a new xy axis, if you will. You can also see that this point right here, this point should really be at 1, 1. sorry, negative 1, 1, which is, this point should be this point over here, but it should be from the corner, 1 this way, and then 1 this way. So it should be like diagonally 1 box or 1 unit, or 1 unit to the left and 1 unit up, or 1 unit away vertically and 1 unit away horizontally. So it should be right here. So what's happened to it is that it's been tripled in height. Okay, that's the point that we're looking at. So it's been tripled in height, which is wherever it is. Okay, the A value is a 3 and then a negative. Okay, so it's tripled in height down here and then flipped. So it's tripled in height, so that's my A value. And then you can also see that the K value hasn't changed. This is 1 away as it should be, and this is 2 away as it should be. Now you may say to yourself, is this tripled in height? Well, remember, this guy should be at negative 2.5, 0.5 here. So 3 times 0.5 is 1. That's 0.5. Then 1 of those, another 1 of those, another 1/2, another half, and another half. And so you get this relationship. So we finally have y is equal to negative 3 over x minus 3 plus 2. That's a very difficult one to sketch. Okay, the root function is very, very daunting for a lot of people. So try those out, see how you do. Okay, I'm going to do a step-by-step transformation for this one. It's an absolute value function, so it's a little bit easier to do. Okay, you could do another mapping method if you wanted to, but I want to be able to exercise the other technique. There also is a little bit of an extra step in here, which is a really important one for us to see and to do. Okay, and that is our factoring step. Our first step is always factor out the value beside x if there's no brackets inside the function. So inside this absolute value function, we just have a 2x minus 2. We need to have a 2 bracket. Okay? If you only had a 2x, then that would be fine. There's nothing to factor out. But you can common factor out a 2. And you end up getting an x minus 1. Okay? And then you have the plus 1 out here. That from there tells me that my A value is already obvious, negative 3. My C value is already obvious, plus 1. Okay, so sorry, I gotta get out of the way because it keeps on brightening up on here. Okay, so my A value is right here on the outside. My C value is right here on the outside, so I write those down. Those are nice and easy. Okay, my K value, okay, I'll always get that because it's a number beside the x, which is 2. But the D value, if you look at this and you say, okay, it's 2, you're going to get an incorrect value. You do have to factor that out of what's ever inside the function. So you take the 2, whatever's beside the x, you factor that out, and whatever you're left over with here, that's your D value. In this case, your D value is also a positive 1. Okay? So what am I going to be doing? I'm going to be stretching 3 times. I'm going to be reflecting vertically. I'm going to be compressing horizontally. And then I'm going to be moving it to the right one and up one. Okay? So let's go ahead and sketch those. We start with our most base function. Let's move over. Most of our work is going to be over here. So I'm going to go step by, oh no, wait, we're going to go down fairly quickly. So we'll have to remember those values. All right, so we draw our base function, which of course is the absolute value of x. There's our basic function. Okay, and I can leave it up here because it's going to be flipping down there anyway, even though it moves up a little bit. Okay? Then what I'm going to be doing is I'm going to be multiplying all my y values by negative 3, or stretching by a factor of 3, and then reflecting. Okay? So I take this value here and I multiply it by negative 3, and what do I get? 0. 0 high, 0 y value times negative 3 is just 0. Now, 1 times negative 3 is going to be a negative 3, so you go down to negative 3, or if you prefer, you take this height and you triple it, so it goes from 1 to 3 all the way up to here, and then you reflect it, and it goes down here. So you can do it in 2 steps if you want to. I'm not going to do it in 2 steps. I'm going to do it in 1. I take this 2, and I multiply it by 3, so it's going to go 1, 2, 3, 4, 5, 6 up here, and then you reflect it all the way down here. Or you take the 2, multiply it by negative 3, and you get negative 6. Oops, negative 6, which is right here. Same thing on the other side. You take a 1, you multiply it by 3, you get -3. You take a 2 and you multiply it by 3 and you get -6. And then you connect the dots from left to right. And that green one is going to be y. I'm going to put it over here because then it's going to be out of the way. Y is equal to 3 times the absolute value of x. Okay? Then what you do, okay, is you go another step further and you say, okay, I'm going to do my horizontal stuff. So you go to do your k value. Your k value is 2. That means you're going to take all the x values and you're going to 1 over to them. 1 over k. So you're going to take the x values and you're going to half them. So this first x value, most people are okay with. This x value here is 0 x value. Halved is still 0. It's invariant. This 1 here is going to be halved, so it's going to be right here. This 2 here is going to be halved, so it's going to go right here. This distance of 2 is going to be halved. And this distance of 1 is going to be halved. And we're left with this super skinny looking function that's been stretched and has been compressed. Stretched vertically and compressed horizontally. So very, very skinny. Okay? And so my blue function is going to be y is equal to 3 times 2x. Then what we're going to do is we're going to move the function. When we move the function, we're going to move it in both d and c directions. D is +1. That's 1 to the right. C is +1. That's going to be 1 upwards. And so as a result, I take every point and I move it to the right 1 and up 1. So I take this point to the right 1 and up 1. Take this point, blue point, to the right 1 and up 1. Take this point, blue point, to the right 1 and up 1. Take this point, move it to the right 1 and up 1. Take this blue point, move it to the right 1, move it up 1. I'll make that a little bit bigger of a circle so you can actually see it on the x-axis. Okay? And I know it looks really ugly. It almost looks like nonsense here. But we're going through here to here and then back down again. And it's kind of ugly, but it is what it is. Okay? So there's y is equal to 3, 2x minus 1 plus 1. And that's what we've sketched there. Kind of ugly, but if we look at this key point, we can still state our domain and our range. Okay, and the domain and the range we can state for this one. We'll do them for both of them. Okay? All right, so if we look carefully at this, our domain and our range, yeah, I can fit it in there. Okay, so domain, range, x such that, y such that, okay? And here, we look at this and we're like, okay, what about x values? We can go to the right or to the left. Negative infinity, no problem. Positive infinity, no problem. But right at the center here, can't have it. What is this asymptote? That is at x, 1, 2, 3, 3, or if you prefer, my d value, which is 3. And of course, we have to write cannot equal to 3. Okay, because that's what an asymptote is, right? You can't put in a 3. And you can see from the equation you can't put in a 3. Because what happens if you put a 3 into there? 3 minus 3 is 0. You can't have 0 in the denominator. So it does make sense. After that, any value is okay, as long as it's not 3. For the y value, it's the same thing. You look at the y asymptote, okay? And it's y cannot equal 2. Now, seeing that y cannot equal 2 is a little bit more difficult. But the idea is this. As my x gets bigger and bigger and bigger and bigger and bigger, the size of this denominator gets bigger and bigger and bigger and bigger and bigger. So much faster that the bottom gets bigger than this thing that stays at -3. So this is going to become 3 over 1, and then 3 over 2, 3 over 3, 3 over 4, 3 over 5, 3 over 6, until it gets like 3 over 300. And then it's like really, really small. It's like 0.01. And then it gets to 3 over like really, really small when this is like 1,000 or 1,000,000 or something. So close to 0 that it's really nothing. And so what ends up happening is it's at 2. Okay, and that's what it approaches. Okay, that's the value that it can never get to. It can never get to because no matter how big you make this fraction, it'll never be 0. It'll get close to it, but not really. So in this case, the y value can't get to 2. It can get really close to 2. It can get really, really close to 2. Okay, but it can't get to 2. Okay, for big x values, because it's a negative. Okay, because it's a negative. Oops. Because we have a negative 3. Really big x values are going to give you a really negative small fraction, which is going to make it really close to 2, but a little bit less than 2. Okay, so that's why it's a little bit less than 2, but really close to 2. And then for this one, of course, negative numbers are going to make this a really big negative number, and that's just going to get really close to 2 as well. But a negative over a negative is going to give you a positive, which is going to add something to the 2 to make it a little bit bigger. And so that's why it's a little bit above it. Okay? We can talk about more of this when we talk about this function better next year. Okay? Domain and range for this function here. Oops, I forgot. As long as x can or y cannot equal 2, then y can be any value. For the domain here, keep on doing that. Y. Lazy. Okay. With my knuckle. Okay, so my domain describes x such that, so what possible x values are allowed, and it looks like they're really narrow, but remember this goes on forever this way, this way, so any value of x is allowed here, and any value of x is allowed here. So this is actually x as a member of real numbers. There's no real restriction on the domain. You'd usually look to the d value to tell you that, but in this case, it's like a parabola. It just keeps on opening up forever and ever and ever and ever and ever. For the y value, though, the y value, we do focus very carefully on your c value. In this case, my c value is 1. And you'll see that. You'll see from this point here, we're going to be looking at the black one. From this point here, anything below, down to negative infinity, no problem. But it doesn't go above 1. It's like a maximum. So greater than, sorry. So then y must be, oops, maybe I'll just erase that mess that I made there anyway. Y must be less than or equal to 1. Okay? Oops, I forgot. Y such that y is going to be less than or equal to 1. Sorry for the doodle, but anyway. It can be 1 or anything smaller. So less than or equal to is a maximum in this case. And as long as it fits that criteria, y is a member of real numbers. Okay? So there you have it. All right, nothing too nuts there. Okay, so those are 2 sketches that we've done with both of our techniques and a little bit of review. Okay, so you're going to be working on this stuff and reviewing this stuff as we go along. There is another page here, and we'll play around with this, but I want to play around with this not on video, but when we're in class. I may do a secondary video of this, okay, to show you how you go about it, because figuring out, there's 2 functions here. One is a quadratic, right, the normal one that we're used to, the parabola. But the other one is this one right here, which is our reciprocal function. That one's a little tougher to do, so I'm going to talk to you a little bit about that one. And I'll even show you some algebraic techniques to show you how to do it, but they're pretty complicated. Okay? This one's actually pretty easy, so I'm going to let you guys try that on your own, and we'll take it up near the end of our lesson. Okay? Block 5 or block 6. And this one I'll also take up at the end of block 5, block 6, but I want you to try that. But this one's a lot more difficult. Okay, that reciprocal function, to ascertain what the actual equation is. And from that you can look at the a and the k and the d and the c value and go from there and write the equation. Okay, and those are a little bit more challenging. Some are a little bit more obvious, some aren't. Okay, so that's that for now. Maybe we'll do another video and shoot how to do that in a second. Okay.